Unit 8, Lesson 2, Probability with Permutations and Combinations. Your objectives for this lesson are to use permutations with probability and to use combinations with probability. Okay, so starting off, a permutation is an arrangement of objects where order is important. Okay, so you're ordering, for instance, first, second, and third place. So something where you have an order. Factorial is used in the definition in the formulas that you're going to see in just a minute. But before we get to there, if you see a number and an exclamation point, it is not just a very happy, excited number. It is a factorial. So you can see here 5 factorial is 5 times 4 times 3 times 2 times 1, and that equals 120. So basically you start with that number and you count down. So 5, 4, 3, 2, 1 till you get to 1. And you multiply everything, all of those numbers together. And then this here, you see n exclamation point, so n factorial. That just explains, that's a more general definition. So n is any number, and this is showing the counting down all the way to 1. Okay, so here are our permutation formulas. The first one, where you have n objects taken r at a time, and we'll see an example of this in a minute, don't worry. So you write this NP, P is for permutation, little r, and this is equal to n factorial over n minus r factorial. Okay, the next one, we have n objects where one is repeated r sub 1 times, another is repeated r sub 2 times, so on and so on. This is our formula, so n factorial over all the r's. And then the last one, where you have n objects in a circle with no fixed reference point. So in this case, your formula is either n factorial divided by n or n minus 1 factorial. So I know that's a lot of formulas getting thrown at you. Just do the best you can. Example 1. What is the probability that a 7-digit telephone number generated using the digits 2, 3, 2, 5, 2, 7, and 3 is the number 222 33 5 7? So what is the probability that this will happen? So let's look at the set of numbers that we're choosing from and count how many of those we're going to have. So we have 1, 2, 3, 4, 5, 6, 7 objects. That means my n is 7. And looking back at our formulas on the previous page, we see a few different r's here. So what is my situation? Do I have n objects taken r at a time, or do I have something repeated? Looking at this set that I'm choosing from, I have repeated objects. So I have 3 2s, and I have 2 3s. Okay? So I'm going to use that second formula. So that is n factorial over r1 factorial, r2 factorial, and so on. Okay, so I know my n is 7, n factorial, over, well, I've circled the repeated objects already. So I see 2 repeats 3 times. That means I have 3 factorial on the bottom, because this is the number of repetitions. 3 repeats 2 times, so I'm going to say over 2 factorial. At this point, I could do this out by hand, and that would work fine. But I'm going to show you how to do factorials in your calculator. So I'm typing in my numerator, 7 factorial. To get to factorial, you're going to hit Math, then go over to probability, it's PRB, number 4. Okay, and that's all you have to do. So divide by, not 4, sorry, 3 factorial times 2 factorial. Okay, and we get 420. So this is the number of possible outcomes. This is the number of possible outcomes I could get with these phone numbers. So the probability that it would be this exact number, well, there's only one way I could get that. So it's going to be 1 over my total. Okay, possible divided by total, 420. Okay, next, probability using combinations. So a combination is an arrangement of objects where order is not important. And if you want to find the number of combinations of n distinct objects taken r at a time, this is written little n, big C, little r, then you're going to use this formula. So n factorial divided by n minus r factorial times r factorial. So you'll probably notice that this first part looks like the this formula here. So it's the permutation formula with an extra r factorial in the denominator. Okay. Example 2. Taryn has 15 soccer trophies, but she only has room to display 9 of them. If she chooses them at random, what is the probability that each of the trophies from the school invitational from the 1st through 9th grades will be chosen? Okay, so how many total do we have? 15. This is n. How many are we choosing out of that? We're choosing 9. That's r. So we're saying NCR equals n factorial over n minus r factorial times r factorial. Okay. So we have 15 choosing 9. Just plugging in. Okay, this is going to tell us the number of different combinations we can have. And again, we're going to use the factorial key. So 15 factorial divided by 15 minus 9 factorial. Notice I used double parentheses on the bottom here. And that gives us 5,005, which means that there are 5,005 different ways that she could choose 9 out of 15. So that many different combinations. But the odds that those specific ones will be chosen, well, the odds for that are 1 out of 5,005. Okay. And quickly, if you wanted to, and I'm sure that you do, you see this is written NCR. Well, in your calculator, if you go back to probability, number 3 you see NCR, and actually number 2 you see NPR. So give me a second, we'll talk about that. So NCR is exactly what we just did. So you could type in 15, that's your N, then go to probability number 3. Now type in your R, which was 9, and we get 5,005. So that's a little bit of a shortcut for you. Okay, and then for NPR, that's this first formula from the permutations. Okay, so for the first formula, you can do that. It's number 2 on probability, but it's not going to work for the other 2. So it only works for that first one. Okay, and that, I believe, yep, that wraps up lesson 2.